Hi and welcome to this screencast on loops. Today I'm going to give a short introduction to for loops and while loops, and I'm going to say a few words on loops versus vectorized computation. Now before we create a for loop, let's just remind ourselves how we can create a list of consecutive numbers in Python. So one way we know is we can use the NumPy array and the function called arange. So I can type np.arange 5, for example. That will give me the numbers 0, 1, 2, 3, and 4 in an array. I can also just type the command range 5. That does pretty much the same thing. But when I do this in a console, it'll just typically just display range 0, 5. If I want to actually list the numbers in the range, I can type list range 5 and get the same numbers out as with the np arrange function. Right. So this is one way or two ways of creating a range of numbers. Now, a for loop can be used to go through a list of numbers and do something for each of the numbers in the list. Right? And the way to write a for loop is to simply type for, and then the name of a variable, I'll call that I, and then you type in, and then the range of numbers you want to go through. So I can just type range 5. That should go through all the numbers 0, 1, 2, 3, and 4. And now, down here underneath, I can now write some lines of code that actually do something with this this number that I'm going through. So what I write here on this line is going to be executed for each possible value of I within this list. So just to do something, I can just print out the value of I here. Now when I run this function, what we see is that it prints out the numbers 0, 1, 2, 3, 4. So basically it repeats this line of code here. And each time it repeats this line, it says I equal to the next value from this vector, range 5. Now just printing out the values is maybe not so interesting. So what we are usually interested in is doing some sort of computation inside the for loop. So for example, let's say we want to compute the sum of all the numbers from 0 to 4. In that case, we could define a variable sum and set that equal to 0 to begin with. And then we can use our for loop to loop over the numbers 0, 1, 2, 3, and 4. And instead of just printing out the value, what we could do is we could take the current value of sum and add I to that. And then we can save the result back into the sum variable. So basically we were updating sum to be its previous value plus I. And then just to keep track of what's happening, maybe we could print out sum here. Okay, so when I run this code, we can see that it prints out some numbers here. So first sum is 0, and now I is going to loop over the values 0, 1, 2, 3, 4. So in the first iteration, I is going to be 0. Sum is 0 and I is 0. It adds that. The result is still 0, and it prints that out. So that's the first number here. Then in the next iteration of the loop, I is going to be 1. So the previous value of sum was 0. It adds 1. And the final value of sum is then 1, which is printed out. In the next iteration, I is going to be 2. The previous value of sum was 1, so it adds 1 and 2 and puts that into sum and prints it out. That's 3. In the next iteration, I is going to be 3. The previous value of sum was 3, so it adds 3 and 3 and prints out the result 6, and so on. Right? So in this way, I can compute the sum of all the numbers from 0 to 4 in a quite easy way. And if I'm just interested in the final result, maybe I'm not interested in printing out all these intermediate values. If I just want the final result, I can just type print sum here all the way down at the end. So when I run the code now, it just prints out the final sum, which is 10. In a for loop, we had to specify exactly which numbers to loop over. So we needed to define a vector of numbers, 1, 2, 3, 4, 5, for example, that we wanted to loop over and do some calculations on. So we needed to specify in advance how many loops or how many iterations of our loop we wanted to have. Now, it's not always the case that we can specify that in advance. And if we can't do that, we can use instead a while loop. So instead of looping over a vector of numbers, a while loop continues to loop and repeat the code until as long as a condition is fulfilled. So I can type while and then a condition. For example, while x is less than 10. So let me define a variable x and set that equal to 5. Now my loop says as long as x is less than 10, I'm going to repeat the following statements. So of course if I just make my code like this, it's just going to say x is 5. As long as x is less than 10, I'm just going to repeat. So it's just going to repeat forever. Right, so that's not very useful. I need to somehow change x inside the loop so that at some point it will be not less than 10 and the loop will then stop. Right, so one way to change x could be, for example, to set x equal to its current value plus 1. So basically add 1 to x. So update x by adding 1. And just to keep track on what's happening here, I can just print out the value of x inside my loop as well. So let me try and run my code here. We can see when I run the code, it prints out the numbers 6, 7, 8, 9, 10. So let's go back and take a look at why that happens. So to begin with, x is 5. And now my loop says as long as x is less than 10, I'm going to repeat these 2 lines of code. So x is 5, that's less than 10. Okay, so let's continue here. Then we add 1 to x, so x becomes 6. And I print out the value of x, so I get this number 6. Now I go back and check my condition again. So x is 6 now. So the condition is 6 is less than 10, and that's true. So I'm going to repeat the loop again. So I add 1 more to x. X becomes 7, and I print out 7. Now I just continue doing this, going back and checking the condition every time. And as long as the condition is true, I'm going to repeat once more. So at some point x is going to be 9. 9 is less than 10, so I need to repeat once more. So here I add 1 to 9, so x becomes 10. I print out 10. And then when I go back and check the condition again, it now says x is 10, so 10 is less than 10. Well, that's not true, that's false. And then my while loop will break and continue executing whatever code is down here below. So in this case, there's no more code, so my program is going to stop. So it prints out the numbers 6, 7, 8, 9, 10, and then it stops repeating. Now we've seen how for loops work, and we also know about how we can do operations directly on vectors. And sometimes a problem can be solved using either of these 2 approaches in 2 quite different ways. So let me try to show that. Let's say we have a vector of numbers v. So this is actually an exercise you've seen before. So let's say we have this vector and we want to compute the square of each element in the vector, but keeping their original sign. So -4, the square is 16, so that should be -16. And 1, for example, the square is 1, so that should just be 1. So using vectorized computation, I could, for example, approach this problem by taking first a look at all the negative values. So I could say the values of v for all the places where v is less than 0. I can give them a new value, and I can take basically their current value, square that, and put a minus in front. Right, so this takes care of all the negative values in v. Now I can do the exact same thing for all the positive ones. All the v's where v is greater than 0 is assigned the value of what their current value is, v of v greater than 0 squared. Okay, and I can finally maybe print out v. When I run this code, we can see that we get the correct results. All the negative values keep their original sign and everything is squared. Now, using a for loop, I can solve this problem in a quite different way, but the result is going to be the same. So let me just copy v down here, and now I can do a for loop instead that loops over all the elements inside the vector v and does this operation of squaring and keeping the sign. So I can write a for loop that says for I in range, and then I'll type in np.size v. Right. So this creates a for loop that loops over the numbers 0, 1, 2, 3, 4 up to the final index of the vector, so the length of the vector. Right. So now I can type v of I, and that will give me the ith element in the vector, and I'm going to loop through all these elements. Now for each element, what I could do is then I could say if the element is negative, then I'm going to do one thing, and what I'll do is I'll take that element and assign a new value, which is the negative of vi squared. If it's not negative, so else, then I'm just going to take vi and assign the value of vi squared without a minus sign. And that's pretty much it. Then at the end I can again print out v like this. So if I run this, now we can see it again prints out exactly the same thing. So the computation is identical, but the code looks very different. So finally, let me just mention that there's another vectorized way that you can write this problem or solve this problem very compactly. So if we have v, we can simply say that v is set equal to the absolute value of v multiplied by v. Right. So if we do this, we are just going to sort of throw away the sign of v once, but keep it in the second copy here. So when we multiply element-wise, we're actually going to get everything squared, but keeping the original sign. So let's try and run that, and we see. Well, let's print out v here again, and we see that once again we get the same result. So to summarize, sometimes a problem can be solved either using a loop or using vectorized computation. The primary reason to choosing one method over the other would be that the code should be as readable and easy to understand as possible. If you're working with very large data sets, very large vectors, then usually a vectorized computation is going to be faster than a loop, but you'll have to try that out and see if that is true in practice. If there's no sort of speed issue, then you should prefer the type of code that makes the code most easy to understand, and both for yourself and to make sure there's no bugs in the code, and also for someone who's going to work with your code later on.